10. And the nice thing is, I'm going to give you a really cool way to figure out exactly what the lowest common. Some people would do 80 here, which is the ECD, the easiest common denominator. Just multiply them together all the time. What do they have in common? What's the biggest number they have in common? 2. 8 is 2 times 4. 10 is 2 times 5. So who's missing what?
So it's 40.
No, it's just who's missing what? What is he missing that he's got?
5.
This is missing a 5, right? Because it's got a 2 and a 4, and this has got a 2 and a 5. So he needs a 5. So maybe I did talk about that. He sounds familiar. And then what's he missing that he's got? 4. Now you can look and say, okay, that's 8 times 5, that's 40. So the LCD would have been 40, right? Now on numbers, when they're smaller like this, I know we didn't have to necessarily do what I just did, but this method actually works really well with bigger numbers that are harder to see. And obviously it works really well with things that aren't fully numbers yet, the ones that have letters in them, right? So here I would get 15 40ths plus 4 40ths. So I could slap them all together here, right? 15 over 40 plus 4 over 40. 19 over 40. Cool. And why do I know I'm done? Because you circled it, Jeff. No, why do I know I'm done? Because you can't reduce it. I love it. So you got to check to make sure you can reduce it, right? If you can't, you're done. So what about this problem here? What problem, John? I don't know. 3 over x squared minus 9 plus 2 over x plus 3.
X minus 3 plus 3.
You first break down the.
So break this guy down.
Right.
X plus 3, x minus 3.
Yeah.
And then what's he missing that he's got?
X minus 3.
X.
Maybe I did talk a little bit about this last time.
Yeah, you did.
Okay. It's almost too easy. Maybe. I don't understand why people have a lot of trouble because it's so, maybe it's so easy that it's like, no, it can't be it. It can't. I know he said it was, but he's crazy. He must be wrong. I mean, this is all there is to it. And again, if you can't factor, no parts of 6 are going to make it for you. But here I just had to see what that's made of to see what this guy needs. They have an x plus 3 in common. He's missing his x minus 3. If I give it to him, now they're both the same denominator, right? So now I can say 3 plus...
2
That's
x
2x
minus
minus
6.
6.
And what's on the bottom?
X plus 3, x minus 3.
No. Leave it factored. Why? Because the last thing you want to do is to see if anything cancels. Bless you. So leave it factored, right?
Right.
Let's see what we get. We get 2x
Minus 3.
minus 3 over x plus 3x. Does anything cancel?
No.
Good. Nothing cancels. Why can you tell? Because you didn't multiply out the bottom. Leave it factored. Don't multiply out the bottom. Leave it. What? I love those specific questions. Which, what, where?
You cross out.
What? Excuse me?
That's 6 and minus 6 is 3.
Did I cross anything out? What do you mean?
No, you didn't.
Thank God.
Maybe it's confused with the 3 because but you can take, 3 from the minus
3 minus 6 is
and you get
negative 3, right? So where did I lose you, man? Well, so are you cool with the first step? Give him what he's missing. So that's a good place to start.
Yeah, what I do, I screwed up completely. I put 3 plus 2 and then kept x minus 3 in its own parentheses and crossed.
Oh, okay. I'm glad you said that. Okay. That's really easy to do.
Thanks for understanding my issue.
So, right here, when you do this here, I try to give you guys ways to keep from doing that. So right here, we gave this guy the x minus 3, right? We gave him this. That's what he was missing. If you don't distribute, if you put it up here like this, the most common next mistake is to think, oh,
No.
well, I don't know how sound you make when you see that. And again, why don't those cancel? Because you can't break into an addition problem. Can't break in there and take a piece of that number away. You can't. But it's so human, I understand why we want to do that. But on one level, it makes absolutely no sense. I needed that so these can go together. If I cancel them, it's like I'm saying, oh, I never really needed them. That doesn't make any sense. I needed them. How can I just cancel them out all of a sudden? I really didn't need them. Right? It doesn't make any sense. But the more direct way of seeing this is you can't cancel parts of an addition problem. You can't. So you've got to distribute. This is the cleanup step. We'll basically never be able to cancel on the second step, because if you try to, you're doing it too early. The top won't be factored, will it? It's going to have this plus or minus. Whatever's in there is going to be in there. So nothing should cancel yet. The second step is always going to be cleanup. Distribute, get your like terms together, and then see if something cancels, right? But I can see why that is just crazy easy to do. Too much crap. You want to get rid of something. I don't blame you. But you do that, you're wrong. So don't do it. Do you guys see that? So now you distribute the two and you get the same place here, right?
2x. Yeah.
And then you finish it out. Cool.
We pull the 2 out. Oh,
No, I put a 2 in.
oh you put 2 in.
Yeah.
Okay.
Okay.
In case
So what-
in the plus, you put the division.
Oh, okay.
Division. So you will flip the 2 plus, put it down.
Oh,
Mistake.
it's not
No,
division.
this one.
Here?
3 divided, division. 3 division by 2.
Oh, no, it's a plus.
No.
If it was.
Yes.
No,
You
no.
can flip it down.
Okay. I got it.
I'm not going to go there right now.
Information.
Yeah, that's a fraction within a fraction. We're not going to look at those. Not yet.
No, just-
No, but you're thinking ahead. I like it. But if that was a division symbol, wouldn't this basically be 3 over this, over this? It would be a fraction inside of a fraction?
Yeah.
Let's not go there yet. Let's hold off on that. You're not going to see that yet.
Scare people to death that way.
That's all right. They happen.
You've
All
had,
right.
you've had no scared to death cases in your classes, I hope.
Pretty close. So let me show you kind of a full-blown out problem, you ready? Or I'm going to show it to you anyway. What do you want? I don't know. Yeah. Sometimes I do this. I'm not sure if it's the best idea in the world, but I want to show you. I mean, I've taken kind of a big step up from that last problem, right? But what I basically want you to understand is I don't care how ugly I make it look. The idea is the same, right? What's the first step here before I can do anything? What do I have to know about the bottoms?
You have to factor them out.
You have to factor them out.
minus 11.
Yeah. So this will be,
Minus 11 plus
Yeah.
3 plus 3 minus
and this one of course is
x minus 3 x minus 3.
X minus.
11. So the first step is you don't care about anything except the denominators. You break them up so you see what they're made of. What do they have in common? Let's start there. What do they have in common?
X
X plus 3.
This is in common. So now you can say, well, what's he missing
X
that
minus
he's
3.
got?
X minus
X
3.
X minus 3.
So you multiply top and bottom by it, right?
X minus 3.
And of course, what's he missing that he's got? It's minus 11. And you see how that process, it's a very simple process. If you can factor, it's easy. It forces the bottoms to be the same, of course, because now everybody's got the same thing on the bottom. They're the same.
X minus 11.
Then you could just focus on the top.
Yes, exactly. So the next step, what's on the bottom?
Yeah.
All those.
All those. Doesn't matter what order, right? They're all multiplication, so you just pick one of the orders and put them down. On the top, I get, we can do this on the next step here.
Yeah.
And of course, here again, Van Will's point's a good one.
Yeah.
Do not start canceling away
No.
because that's subtraction, right?
Yeah.
No.
But it's so easy to say, I want to do that because it's going to make my problem easier. That Jeff dude, he's making everything complicated. If I just cancel those out, it's an easier problem. Sure, it's an easier problem. It's not the same problem.
But you're gonna foil
Okay,
them
so
out.
now what?
Foil.
So now what? Now it's the cleanup step. You see how it's always the same. Break up the bottoms, who's missing what, give it to them, clean it up. Multiply stuff out, get your like terms together. right?
Yeah.
So I foil this bad boy, foil that bad boy.
Ah.
Over here, what do we gotta be careful about? This is the other thing that always trips me up.
Minus.
Whatever I get here, I've gotta change all the signs.
It will change all, yeah.
So here I'm gonna get
Four X.
4x squared minus 12x.
yeah, minus 12, minus 7, so minus 19. Is that cool?
Yeah. Yeah.
Thanks.
So in the middle, I just put the two together. Just trying to save some room here.
Plus 21.
Plus 21 minus
minus x squared.
x squared plus 2 minus 11. So minus 9.
Minus 9. Minus
2,
22.
2, 2.
Plus 2 minus 11.
So
Ah,
it will change.
Right? Plus 2x
minus
minus
11.
11x makes
Yeah.
minus 9x. So I'm skipping a step there that you don't have to skip, but I just want to get there. Do you see how I left the parentheses there? Why? Because that minus has got to go to everything.
So you can distribute it.
That's the easiest mistake to make on that, is just to forget to change your signs. All over, blah, blah, blah,
Yeah.
right?
X minus 11.
And this is another problem. This is a whole other section where stamina comes into play. You're like, shit, I've already done a lot of crap, and
Yeah.
I'm not done with this. I'm
screwed.
done.
right? And I feel like a little old man about to say I walk uphill both ways. When I had homework that was, one problem took 7 pages, I don't want to hear about this. Right? But you guys are like, that's you, Jeff. You did all the math crap. But this isn't that bad. Take each step one thing at a time. This is just a foiling problem,
Yeah.
Now it's a like terms problem,
Right.
Yeah.
right?
Yeah.
You got to change the signs there on the top.
Yeah, 4x squared. No.
Yeah.
Yeah.
Where about at 19 plus 21?
Minus x squared
Okay.
Plus.
plus
Plus.
9x
Plus.
plus 22, right?
Yeah.
Right.
Change the signs
So you have
3x2.
all over this.
3x. Where?
3x2.
Yeah, 3x squared. Now it's like terms. Yeah, 3x squared
10 minus 10.
minus 10x,
1.
43.
43. They're both positive, right?
We're done yet?
Now this one you'd have to take a second
Yeah.
and see. Now isn't 43 prime?
Yes.
43 is prime.
Yeah.
So 3 times 43 is 129. There's only one way really to break it. 3 and 43 or 129 and 1.
Math does not even.
And will that ever make 10?
No.
No.
So that's prime.
Okay.
So don't pull your hair out. Not all of them. In fact, I haven't looked here, but I would say around half of them maybe will reduce at the end, maybe a little more. They won't all reduce, so don't think that don't get overzealous and say they're all prime. This one's very obviously prime. I can never make 10 with what I've got. Right? So I know I'm done.
So if it did break down,
Then you'd have to break it down and see maybe something I'll
you
cancel.
cancel.
Yeah.
Right?
Cool. So I'm gonna give you guys one to try. It's not quite that evil. That's the almost the worst one you'd see. And I understand why you guys would say that's kind of long. 2 things, it really isn't that long, and each step is easy. If I said foil this, if that was a problem I gave you, go, oh please, yes, Jeff. So that's foil this. Like terms. So you've just got to identify what's the important thing right on this step. What you guys do is you look at the whole thing and you go, holy shit. Well, this is just take the negative through. That's all I care about right there. I don't care about all this other crap, right? Focus on what's important right now. You guys have this here?
Yeah.
This colorful mess? All right.
Oh, wait.
I could hear in your voice that you were telling me the truth. I thought you'd be a better BS. All right. I'm disappointed. Yeah. What are they teaching people in college now? So here, you guys try this one. See if I make one that works. That might be better. Would that be nice? I gotta keep track of what I'm doing.